Jai Hind. Today we are going to start the subject Civil Engineering Material Testing and Evaluation. In this subject we are going to study different types of materials, their testings and the evaluation. As we all know that the field of civil engineering is very important in every sector. We have to study different types of materials, their compositions, their durabilities, properties and many more. We know that the different types of materials are going to be used in the various types of constructions. From skyscrapers to the highway engineering, we need different types of compositions for the structures. This course delves into the fundamental principles of materials, science testing techniques and the evaluation of materials used in civil engineering applications. In this, today we are going to start the cement. Basically, cement is a building material. It is invented in 1824 by the Joseph Aspidel. It is a fine grey powder that hardens when mixed with the water. Basically, cement is having a properties of cohesive and adhesive. It is a binding material. It is used to bind the cement, sand and gravels to make a concrete. When we were talking about the cement, cement can be broadly classified into two types. First one is the hydraulic cement and the other than is the non-hydraulic cement. Yes. When we were talking about the hydraulic cement, it sets and becomes adhesive due to the chemical reaction between the dry ingredients and the water. Means when we are going to use a hydraulic cement, it takes the reactions between their dry ingredients and water. While other than that, when we were talking about the hydraulic cement, it does not set in the wet condition. It means it needs CO2. It hardens when it is come in contact with the CO2 present in the air, and it is resistance attacked by chemicals after setting. So generally the type of cement we were using, that is of a hydraulic cement. For the example, in India the most of the cement used is of Portland cement. Now what are the applications where cement is going to be used? When we will take cement, sand and water, it becomes mortar. It is used in the plastering of walls. When cement, sand and aggregate mixed together, it becomes a concrete which is used for the flooring purpose. When this concrete is mixed with the rebars, then it is formed as a RCC, that is reinforced cement concrete, and it imparts very high tensile strength. Furthermore, yes, what are the chemical compositions of the cement? Cement, as I have told in the last slide, cement is a very fine material. It is a grayish in color with the shade of light green, and it composes of so many chemical compositions. The major compositions used in this are lime, silica, alumina, iron oxide, magnesium, potash and sulfur trioxide. When we were talking about this, the main ingredients used in the chemical composition of cement or the making of the cement, that is lime, silica and alumina. Now these percentages are varies, like lime, it will be in the range of 60 to 65%. Silica, it is in the range of 17 to 25%. Alumina 3 to 8%. Iron oxide 0.5 to 6%. Magnesia is 0.5 to 4%. Potash and soda is 0.5 to 1. Alkalis. And sulfur trioxide is 1 to 2%. And the average ranges are, here it is. Lime is for the 63. Silica is 20. Alumina is 6. Iron oxide is 3. Magnesia 2. Soda or potash is 1. And sulfur trioxide is 1.5. Now, here the percentage of cement ingredients. The major quantities of the ingredients of cement is lime, silica and alumina. Lime, silica and alumina. As we can see that is in the high percentage. Alumina 60, silica 75 and alumina 3 to 8%. So these are the major constituents which is used. It provides strength to the cement and finally it gives strength. Now, in the minor ingredients, In minor ingredients, there are magnesium, calcium sulfate, sulfur trioxide and alkalines. Now, let's discuss all of these compositions one by one to get the details in. Now, the first one is lime. What is the lime role? Why lime is used in the cement? What are the major constituents and what happens if we are going to use that lime in a lower portion or in the axis? What the things will be happen? Now, let's see first the lime. As we all know that lime is come in the percentage of 60 to 65. Lime is going to in the form of 60 to 65%. Okay? Yes. And the presence of limes in cement is essential for the formation of silicates and aluminates. Yes. When we were going to talk about the strength, when we are going to talk about the binding, then these two are play the major roles. Silicates and aluminates of calciums, which are crucial for the strength of the final product. So that is the main thing which is provide the strength to the structure. It is good. Now, it also affects the setting time. Deficiency means if we are going to use the minimum percentage, that is range between 60 to 65. If we are going to use this in a less percentage of this, then it causes the cement to set quickly. If we are going to use in excess, means more than 65%, if we are going to use it more than 65%, then it makes the cement unsound. It means there will be other change in volume. There will be the change in the volume. So that is the rule that we should have to take the compositions within the range. If we are going to use it in an axis, then it will make a problem. If we are going to take it in a lower range, then it also be a problem for this. So maintaining, so there should be a must one optimum level for this one. Maintaining the right balance of lime and cement is crucial. So we have to not be in the deficiency or in the axis. It impact in a negative manner. It means it. What are the impacts? It makes cement unsound. Okay, then it will make the cement as a unsound. Now, that is the role of lime. Now the next one is silica. Now, silica is also the important parameter in the compositions of cement. When we were talking about the silica, calcium, silica, both are responsible for the strength. They both provide strength to the final outcome of the structures. Silica, silica oxide, both are the three ingredients that provide strength to the cement. So it has to be in a sufficient quantity. It should not be less than or in the excess. Now, it provides strength. Otherwise, if it will it will give the overall soundness to the performance of the final structure. Now, the next one is the aluminum. It imparts quick setting. It gives quick setting to the cement. If it is in the axis, so there is a fixed range for this also. If it is going to be in the axis, it weakens the strength. Means in a somehow it will provide strength, but if it is provided in the axis, it will give the weak. It will make the cement weak. Magnesia and its impact. What is the role of the magnesia? So excess magnesia is also weaken the cement. It is also going to weaken the cement if it is in the axis proportion. maintaining the right and the balancing, it is very more important for the overall performance and the durability. Because we have seen in so many structures there are some durability problems related to that. Now after that we have to maintain some optimum level, means we have to maintain some percentage for this. For making the percentages, it should not be in the excess of 2%, means the highest limit is 2%. If we are making it more than 2%, then it will decreases the strength, then it will going to decrease the strength. And it will going to reduce or decrease the strength of the final product. So that is the role of the magnesium in the cement. Now what is the role of iron oxide in the contribution to the cement? So it imparts color. It imparts color to the cement, as if we know that it is of grey color. It is of light grey color with a light greenish shade. So it gives color to the cement. It also enhances the hardness and the strength of the cement. That is, there are the two roles. That one is the color to the cement, and at high temperatures when iron oxide can react with calcium and aluminium to form tricalcium aluminoferrite, which can use or which can enhance the hardness and the strength of the cement. Now further move forward to the next slide, that is the alkaline consideration. Very important. The value should not be more than 1%. Because if it is more than 1%, then it causes efflorescence. You have seen so many times here is a one thin fine layer of white things out of the structures, which is nothing but than the efflorescence. That is due to the more limit of alkalines present in that final product. So excess alkaline matters can cause efflorescence, which is a formation of white powder deposits on the surface of the cement. And it is very important to control it. So careful monitoring of this is required, and it can be ensured at the long term. Means it shows in the long term effect. It shows in a long term effect. It is of white powder form layer. So that is all about the chemical compositions of cement. Just to take a quick recall that these three provides the strength. It will come into the range of 60 to 65. If it is in excess to that, it will make cement unsound, and it's give color to the cement. Here it is all about the chemical compositions. Now